Okay, moving on to the next section where we'll be looking at the real and ideal gas. So this part here is important for you to know that you're expected to know how to state the basic assumption of the kinetic theory as applied to an ideal gas. Okay, so basically you must remember that an ideal gas is a gas that obeys the general gas equation PV equals nRT under all conditions of temperature and pressure. So in other words, right, if I were to ask you what is the definition of an ideal gas, this will be the answer. Definition of ideal gas. An ideal gas is a gas that obeys the general gas equation PV equals nRT at all conditions of temperature and pressure. Okay, so then we must know that there are some assumption of an ideal gas. In other words, right, ideal gas is hypothetical, it is not real, and we are making some assumption of how it should behave. So the first assumption is that the volume or the molecular size of a gas particle, I want you all to underline the word particle because this is important to note, to include in your answer. So the volume of the gas particle, right, is considered as negligible compared to the volume of the container. The volume of the container is equivalent to the total volume occupied by the gas. In other words, if I have a container like this, right, what we are trying to say is that the size of the particle is so tiny that it is actually considered as so insignificant and negligible, such that it is as good as like it is not occupying much space within the container itself. So then the second assumption that we have is that the forces of attraction between the gas particle is considered as negligible or insignificant. So what does it mean is that if we know, right, all gas by right, technically we learned this in chem bonding, right, they should have some form of intermolecular forces of attraction. Minimally, they should all have IDID. Some will have PDPD. Some will even have hydrogen bonding. So we are saying that this interaction, right, is so weak and so insignificant that the gas particle don't actually attract one another at all. Okay, so that is the assumption. Okay, so you notice that the first two assumption, right, is intentionally of a larger font because these two assumptions are the most important. So you may want to asterisk and tell yourself that you need to know these two minimally. Okay, but it is good to know more than just two. Later on, I'll show you an example of an A-level question and you'll be convinced that it is important to know more than just two. So the third assumption that we have is that when the particles collide, right, the collision is perfectly elastic. So what does it mean? It means that when they collide, there is actually no loss of kinetic energy. And the fourth assumption is that the gas particles are always in constant random motion. They will collide occasionally with one another and against the wall of the container. And finally, the next assumption is that the average kinetic energy of the particle, right, is proportional to its absolute temperature. So remember, absolute temperature is always measured in terms of kelvins. So this will be the five assumption of an ideal gas. Here I want to show you an example of an A-level question, very recent, 2021, A-level paper 3 question 2. You are told that you're expected to be able to state the three basic assumptions of kinetic theory as applied to an ideal gas. So notice that 2 is not enough. They want you to give 3, even though only 2 marks is given. So when you are stating the assumption, right, so again, I want like that you must say that the volume, the molecular size or the volume of the gas particle. So I want to underline the word gas particle is negligible compared to the volume of the container, or you can say it's negligible compared to the total volume of occupied by the gas. Okay, so I want to highlight that it is wrong to say that the volume of gas is negligible compared to volume of container. If you just simply write like that, right, you will be marked wrong. Why? Because you didn't specify that you're talking about the particle. Okay, so the word particle is important. Sometimes if you don't want to use the word particle, you can also use the word molecular. So this keyword is important. Okay, then of course you can also state the other assumption, the negligible forces of attraction between a gas particle. And you can also talk about collision being perfectly elastic lah. So usually the first three are the most commonly quoted answer. Alright. So actually this list here, the assumption here, right, is as good as the characteristic of an ideal gas. As I mentioned just now, ideal gas is hypothetical. There's no such thing as ideal gas. So in other words, right, what we have in reality is called real gas. So and what we notice about the characteristic of a real gas is that the volume of the gas particle is not completely negligible compared to the volume of the container. Why is it so? Because we all know that gas have a finite volume and size. So this means that it violates the first assumption that we have of an ideal gas, right? And then we also know that no matter what, the gas particle will have some form of attraction. The attraction can be IDID, can be PDBD, can be hydrogen bonding. So though they are weak, right, but yet it is not negligible. So this will violate assumption 2 of an ideal gas. So that is the reason why is it that we don't really have ideal gas. What we can only do is to adjust the conditions such that the real gas will behave more and more like an ideal gas. Can? So, and then of course we know that the collision, right, when the particles collide will not be elastic. There will definitely be loss of kinetic energy. So yeah, so in the next section, right, we'll actually be looking at the deviation from ideal gas behavior. We'll find out under what condition will the real gas behave most like an ideal gas.